concern. This is just for your concern that I have started recording of this session and this will be shared with you all, right? Okay, so today we are going to discuss about 3-tier infrastructure architecture. So guys, is there anyone who can help me with like what is 3-tier? Why do we call it 3-tier? And what all these 3 tiers are? Yes, guys, anyone who can help me with this?
Okay, sir, can I try?
Yeah, sure, please, why not?
Okay, so we have 3 layers in like each organization. So first layer would be web servers.
Okay.
And like wherein we have like Nginx, Apache. Okay. And the second layer would be app server there. In that we can JBoss, WebLogic, and Tomcat. And third layer is like a database layer, wherein we can Postgres, MySQL, Oracle, this kind of options we have.
Okay. So these are known as 3 layers. Absolutely true. So guys, let me tell you, if you remember yesterday, we were talking about some different concepts. We were talking about here DMZ zone, prod zone, DB zone, TND, different type of environment based on use cases like production, pre-prod, UAT, SIT, QA, or dev, right? Aside to that, we discussed about like type of servers like physical server, right? We talked about VM host, which are known as guest operating system. We talked about containerization platform, right? So these sort of things we discussed about. But if I tell you something about like if we need to explain that how do we set up 3-tier architecture. So guys, this is going to be quite interesting today. So first of all, if someone is going to ask you during interview, okay, can you explain about your infrastructure architecture? So guys, you have to say that we are using 3-tier architecture, and these tiers includes web servers, application servers, and DB servers. Now, furthermore, now you will add quickly that all these 3 servers are distributed based on network isolation into DMZ zone, prod zone, and DB zone. These 3 zones you will definitely have to introduce. Only then you shall be able to say that yes, you know the infrastructure in a proper manner. So guys, where will the web server be available? In DMZ zone. Where will app server lie? In prod zone. And DB zone will not have any sort of internet connectivity. Right, guys? Moreover, one more thing. Let us say we have internet here. Let us call it internet. Right? We have internet. Now, based on this, there is a particular user. Right, guys? This is a user, end user, trying to access. Let us say this user has some laptop. Let us make it a little fancy today. So this user is trying to access this particular website. The website name is https://www.servergyan.com. This user is trying to access this website over internet. Now, what will be the very first component where the request will land? So, right, guys, keep this thing in mind. First of all, we have a component which is known as DNS. So, it could be a public, it will obviously be a public DNS. For example, if you are going to explain based on AWS, you will say that request goes to DNS. In our case, that is Route 53, because Route 53 works as a global load balancer as well as a DNS. So you will say that a request goes to our DNS. Now, based on this particular DNS, what happens here? Request will be forwarded to a particular infrastructure environment, which is inside your some VPC. Right, guys? Do let me know if we have any sort of conflict anywhere. So now, guys, what would happen? From this particular actor, request will go to internet to DNS. And now from DNS, the request will start flowing towards our internal components. First of all, if we are using any sort of component which is on-prem data center, then first of all, there will be component known as firewall. Right, guys? Request will go to a firewall. Keep this thing in mind, guys. If we are not using internet like on-prem data center, then request will definitely go to some load balancer, which is known as ELB. Yes, guys. So request will go to load balancer. And guys, keep this thing in mind. Load balancer is such a component which is kept inside our VPC. Because right now, guys, we are talking about inside a VPC. VPC details, we will discuss about like how do we set it, what are the components of it, how do we ensure that everything is working as per expectation. Each and everything is placed as per the high availability manner. So guys, we are going to keep this load balancer here. And now the particular piece of security which I was talking about. So guys, keep this thing in mind. We are going to attach a security group here. So rather than calling that request will go to like firewall, so we are going to associate a particular security group along with this application load balancer. Right, guys? If you want, I can just give it a name like app ELB. Let me reduce the size of it to maybe 18. Yes, that will work. So guys, this is going to be application load balancer. Are we clear with this? Why we are going to use this as application load balancer, guys?
Yes, sir.
Why?
Because it can do host-based routing or path-based routing for us.
Okay. So the answer is right, but not up to that level where it should be. So rather than saying that we can do host-based routing or path-based routing, we should be saying that the particular the traffic which we are accepting from internet, that is based on HTTP or HTTPS. Application load balancer works on layer 7, right? And HTTP or HTTPS are the protocol of layer 7 only. That is why we are going to say that we will use an application load balancer, and we can secure our application load balancer with the help of some security group, right, guys? So we can easily say that we are going to associate one elastic load balancer here, one application load balancer, right, guys? Clear, guys?
Yes.
We are going to associate one security group in order to ensure that our load balancer is secure, that and all the traffic which is going to enter into this load balancer, that is scanned properly. Now, guys, the very first layer, and guys, keep this thing in mind. What we are doing right now, we are going to keep this load balancer inside DMZ zone, because web servers are placed in such a zone which is known as DMZ, demilitarized zone, where we are going to have two type of IP addresses, and these IP addresses will be public as well as private IP address, guys. Keep this thing in mind. So guys, web server will forward the request onto different application servers, and these application server will be like this. This will be my first web server, and like number of web server will be depending only on the requirement of traffic. For example, we are going to have 1000 hit per second, or maybe 100 hits per second, maybe 10 hits per second. So number of nodes will be depending only on the requirement, right, guys? So we will have here web server, let us call it 1, and where it is, like let's say AP South 1A. This is our first availability zone. This is web server 1, and this is placed in AP South 1. AP South 1 means Mumbai. If we go here on this dashboard, if we try to see the like availability zone like AP South 1, so this is the particular code for Mumbai region, and inside Mumbai we have A, B, and C, like 3 different data centers we have, which is known as availability zone, right, guys? Okay, the second web server which we are going to have here, that will be web server 2, and that will be inside 1B. Why it is, and why we are going to do this particular thing, guys? Because we want to ensure that if in any case, if our like this particular region goes down, then this particular load balancer, this particular web server should be able to serve the traffic in the same way as like previous one was serving. Right, guys? So this is going to be like web server number 3 based on like requirement, and this is going to be in 1C. Are we clear, guys? And then this particular big box here, what do we call it? We give it a name as target group. Guys, what do we call this particular segment? A target
group.
Right. So how we are going to explain that whenever a user requests our domain name, which is servergan.com. So first of all, the request goes to DNS. DNS is resolving the domain name against an application load balancer, which is application load balancer in our case, right? That application load balancer further distributes load into a target group where multiple web servers are running. If you want to be specific, you can. If you don't want to be specific, there is no need to be. If someone is going to ask that how many web servers you have, in that case, you can say that like we have 10 servers, we have 15 web servers, we have 20 web servers, or whatever number based on the requirements. The ideal size, let us say if you are working with a mid-level of organization, then 8 to 10 web servers are good enough, because if we are serving 2 to 3,000 concurrent users in parallel, then 5 web servers are more than good enough. Moreover, that will be depending on the size of those web servers. If size is 16 CPU and 32 GB of RAM, that is good enough. Up to 5,000 concurrent users, these 5 web servers can support. But if the size is 16 CPU and 32 GB of RAM. Moreover, guys, I would not be 100% sure of it that like how have you optimized your servers? So it completely depends on the optimization level as well. So I would rather say that before giving a particular number to any interviewer, we need to be quite sure that how we are going to manage it. So we will once again add one more thing here, that in order to define the number of web servers inside a target group, we go for load testing before setting up the number of servers based on the requirement. And guys, how do we perform load testing? So either we can have Postman, we can have Selenium, and we can have other automation tool as well in order to go for this one. So are we clear so far, guys? Like we have an actor, like we have a user is hitting the domain name into laptop, www.servergan.com, request will go to DNS. From DNS, it will be redirected to auto scaling group. Sorry, it will be redirected to load balancer. Load balancer will further forward the request to one target group where multiple servers are available. Are we clear so far, guys? Any question?
Yes, sir.
Sir, can we add NIC card like whenever user entered request on his laptop, first it will goes to the NIC card of laptop, try to resolve the DNS by local DNS.
We will come on to that when we will talk about DNS workflow.
Okay, all right.
Because in that particular case, someone might ask you, when you enter a domain name into a browser, what happens?
Yes.
Right now, you are not talking about the DNS workflow. Right now, you are trying to explain the particular architecture of your application. So in your application architecture, your laptop does not play any role.
Okay.
Over here, you are going to say that when a user, or you can call that actor, when an actor hits the domain name into browser, request will go to DNS, then to application load balancer, then to target group. Now, this is the first layer. Now, guys, once again, we are going to have the same setup here. So if you see, we have same setup, and wait, we will have to have same setup, and we are going to place it like this. And what we are trying to do here, guys, we are trying to create some application servers here. Guys, this is going to be our app server. Number of app servers and web servers may be different. It is not always necessary that we are going to have same number of web servers and app server in our organization. These could be different. Let us say we have 5 web servers and 10 app servers, because the amount of compute which we have to perform on any application server, that might be different. Keep this thing in mind, guys. The level of compute, the amount of computation we have to perform on web and app server could be different. So we may not be 100% sure that we are going to use same amount of servers into web application for web application and for application servers, right guys? Okay, so once again we have three application servers here. Now guys, how we are going to distribute load from here to here? This time we will have once again a particular server which is known as application server. Okay, this will be once again a load balancer, and this will be, let me call it, network load balancer. Guys, what kind of load balancer will it be?
Network load balancer.
Moreover, we need to ensure one more thing. We need to define over here. We are not going to accept any sort of HTTP or HTTPS request, and this will be furthermore internal load balancer. We are going to have this load balancer as internal load balancer, because this load balancer will not accept any traffic from like internet. It will be accepting traffic only from these web servers. So what would happen? Let us say these application servers are running on any specific port. Let us say the port number for these application servers are, let me give a particular example. This app server is running on port number, let us say 8080, right? So what would happen? This particular web server will forward a request onto, obviously when we are going to associate a particular target group here, right guys? So that target group will have a particular listener. This load balancer will have a listener, right? So let us say we are going to associate a listener, and that listener along with this particular server is going to work on, let us say, port number 8080. What is going to be the listener port number, guys? 8080. So guys, this is a listener. Whenever these web servers would want to send traffic to these application servers, so rather than forwarding traffic directly to this server, there will be a load balancer. That will be a network load balancer, and that will be internal network load balancer having a listener enabled on port number 8080. So whenever these web servers will try to forward a request, right guys, whenever these web servers will try to forward a request, these web server will forward request to this network load balancer on port number 8080. Furthermore, it will forward the request onto this target group, where we already have 3 web servers listening on port number 808. These are the app servers, right? So these servers will be ready to accept traffic on port number 8080. Are we clear with this thing, guys? Any questions so far? Guys, any questions so far?
No, sir.
Okay, any other one has any question? Anyone? Do I explain things that much well that people have no questions? Parmesh ready? Any question? Pradeep ready? Any question?
Yeah, one quick question. So do you add any security group to this internal ELB here, or like?
Yes, a pretty fantastic question you asked. I was expecting that sort of. That's why I specifically mentioned your security group. Network load balancer does not allow us to have any security group. We cannot secure our network load balancer with the help of any security group. Or whatever traffic has to be allowed or denied, that will be done on this particular application layer only, on the instance layer only. We can attach a security group with this application load balancer, not with network load balancer, right? That is also one interview question even I was asking yesterday itself. Right, guys? Now one more question will be there. How the question is going to be? So the question would be like, okay, let us say you have n number of web servers available in your single target group, then how you are going to handle that? If number of web servers are supposed to be increased or are supposed to be reduced based on the particular requirement, then how do we handle that situation? So guys, we have another component known as auto scaling. So guys, we have a component known as auto scaling. We will have an auto scaling group associated with this. We will place that auto scaling group somewhere here, which means whenever there's a requirement to increase number of instances within this group, let me give it a name. Shall I define your ASG auto scaling group? Will it work?
Yes.
Okay, we have this auto scaling group available here. Now guys, along with this, there will be two configurations. Either it will be launch configuration template. It will be launch template or launch configuration. Right, guys? Just a moment.
Yes, sir.
Just a moment. Give me a moment. There's a call. Yes, guys. So, like, how does it work? So we have an auto scaling group. Now there can be a cross question that how will you ensure that the particular launch configuration is going to create, or the particular auto scaling group is going to create web server that will have all the available configurations which are right now available here. Any answer for the question, guys?
We can make it good in AMI.
Okay, one by one. Yes. Who will explain first?
I'll go first.
Yeah,
We
please.
can make it good in AMI from one of the instances. Then we can include in our launch configuration or launch template.
Yes, very true. What else? Anyone else? Because we should not all have only one answer. Yes, Ismail, you wanted to say something?
So same like in launch configuration, we provide the AMI, and accordingly it will spin up the server.
Great. Good to know. Okay, so let me tell you guys, there could be like 2 or 3 approaches. Very first approach is, yes, you all are right. Whenever we do a deployment, post doing deployment, we would have a particular AMI created. And after that, we will update that AMI into launch template or launch configuration, whatever we are using in order to manage this target group from auto scaling group, right? That is first approach. Second approach could be when, like, let us say we have our like configuration available on GitHub or maybe some S3 bucket. Whenever we are going to spin up a new server. So guys, if you remember that we have a particular option known as user data. At the time of EC2 machine creation, we have an option known as user data. What would happen? Maximum the application configuration or like web server configuration files are supposed to be updated. Rest all things are going to remain same because number of users will already be part of that AMI. Let us say that the type of rules which we have on that server, that will also be part of it. All the security hardening will also be part of that. Only the application property or like web server configuration part will get modified from last deployment to current, right? So what is supposed to be done? So either we can create AMI after every deployment, or whenever we make modification within Nginx configuration file, maybe Apache Tomcat configuration file, or maybe Apache web server configuration file, we are supposed to push that file to some GitHub, maybe some Bitbucket repository or some GitLab repository, right? We can pass some credential into our user data section. Maybe we can push the same file to some S3 bucket, and from there we can download the configuration file, and we can place the file before the server comes into running instance. Right, guys? These are the two approaches which we can follow. Moreover, if we are using some like AWS deployment tools we are using, let us say we are using AWS code pipeline, code deploy. So in that case, we can create some webhooks that whenever a server is getting created inside a target group, so we can download the configuration files from S3 bucket. Once again, the same thing will be done, like rather than using user data section, we are talking about like code deploy or like a code pipeline. Using that particular way we can keep our server up to date. Clear, guys? Same thing will happen in case of application server as well. Like whenever there is a requirement to upgrade or downgrade the like number of servers, so we are going to perform the same thing. And let us say like if we have any launch configuration, do we have anything on a launch template? Launch configuration? No, sorry, no icon is available. So I can just type in here launch template. Launch templates, let's configure. Right, guys? So there are two components along which are associated, like which works hand in hand with this particular auto scaling group. And what are the components, guys? Either it will be launch configuration or launch template. Right, guys? Clear? Any doubt so far, guys? Guys, any questions so far?
No.
Okay, great. Sounds good. So guys, what is going to happen here? First of all, we have web server. Then after we have application server. We have a security group associated with this web application load balancer. We have a network load balancer listing on port number 8080. And whenever we are talking about this particular port number, like this load balancer, so guys, we can say that we have port number 80 and 443 associated with it, because right now, because whenever we accept traffic from internet, so that traffic is accepted either on port number 80 or port number 443. So if you have to answer any query related like what particular port numbers we have whitelisted or something like, so what would you answer, guys, here? That we have whitelisted port number 80 and 443 onto our application load balancer. Clear, guys? Okay, one more thing we can add here, that whenever request comes onto port number 80, we will redirect that request to port number 443, because we do not want our user to initiate any insecure connection onto our load balancer. But we do not want to restrict our user that while typing a particular domain name into browser, they should be explicitly defining HTTPS along with the domain name. So what do we do here is, for example, if I type in any URL here, for example, I'm typing here google.com. Right, guys? So what is it? Did I define any HTTPS or anything else here? No? We will go to inspect section. We will go to network section. And if I hit enter here, just see, guys, what is going to happen. The very first thing which is happening here. So what is the very first request, guys, going? That is 301 redirect from HTTP to HTTPS. Clear, guys? Like whenever we type in, like the particular request which I typed in, that was for HTTP, and that has been like the very first response code here is HTTPS, but I typed in there HTTP, which means if we go to this particular diagram, we can easily say that we do not restrict our users to type in any explicit domain name into a browser with any specific protocol. Our users are allowed to type in any URL, like let us say it is for HTTP or for HTTPS, but we have placed a rule onto our application load balancer that whenever a user is typing in a domain name with HTTP, so our load balancer redirects that request automatically to HTTPS URL. Are we clear with that, guys? Guys, are we clear with that? Any question so far? Shiv, any question?
No. Okay.
Great. Sounds good. One more thing, guys, we need to be very, very careful about. And what is that? So when we are talking about like what type of load balancer do we have? Why do we have this configuration and all? So guys, keep this thing in mind. There can be one another question. Let us say we are accepting currently we are serving maybe 5 million hits per second. That can be hypothetical question. So let us say we are serving 5 million hits per second and we want to migrate our infrastructure from on-prem to AWS. So will this application load balancer will be able to handle that amount of request? So what should be the answer, guys, here? So the answer should be in such a way that the application load balancer which we are going to create by default, it will not support or it may be able to support. But when we know that we are actually going to serve really huge amount of traffic from this particular load balancer, so we have to raise a request to AWS team in order to provision up like pre-warmed load balancer. That is known as pre-warmed. Now, what does that mean, pre-warmed load balancer, guys? We will let AWS know that the amount of traffic which we are going to serve from this load balancer is going to be huge. We are expecting at least 5 million hits per second onto this load balancer. So AWS team will ensure to provision our load balancer onto such a hardware that is capable enough to handle 5 million hits per second. And what do we call that, guys?
Pre-warm.
Pre-warmed load balancers. That's the key word here. That is known as pre-warmed load balancer. Okay. So I hope that we are clear so far, guys. Okay, let us move ahead. Once again, guys, we are going to have once again the same concept we are going to have. Okay, let me copy this. Otherwise, I'll have to do rework once again. So, guys, we are going to have here. What particular layer is going to be here, guys?
Database layer.
Database layer.
Great. Fantastic. We have DB servers here. Let us say we are going to work with MySQL, for example, 3306 is the port number. We will have 3 instances here, like 1A, then after in 1B, then after in 1C. The same way, like 3 DB we are going to have. But guys, as we all know, so database, we do not have all the database as master. There is only one master and 2 replica set we have. Like 2 slaves and 1 master usually we have, guys, right? Once again, we are going to have here what? A network load balancer. Let us say we have a particular proxy server. And guys, keep this thing in mind. We are going to introduce one more component here. And that is known as, okay. Which one should I use? Maybe this one? No.
Why do you need a load balancer when it goes to only one node all the time?
Coming on to that, buddy. I can completely understand your curiosity. But the particular level of architecture which we are going to explain is going to be huge. Okay. So guys, this is a particular component which is known as Proxy SQL. What is it? What is it called? Proxy SQL. So guys, whenever we are going to accept, let us say our proxy is running on 6033 port number. So whenever we want to connect to this Proxy SQL, guys, like we will hit from here and the request will get connected to this particular place, like Proxy SQL. So guys, what is going to happen? We will forward all the requests coming from these application servers. Right now, guys, who is supposed to connect to this particular web DB server? Obviously, the particular application servers are supposed to initiate connection with DB servers. But guys, how are we sure about it that the particular read request will be forwarded to this one? And right, let us say this is master. Let me define m dash db, like master db, and let us say we will define here s dash db. Once again, I'll have to define here s. So yes, guys, do we have any mechanism using which we can define that when this application server is going to update, insert, alter, delete, anything except from select, that should be forwarded here onto this master database. And if request is related to select, that should be forwarded here onto these two DB servers. And guys, let me tell you, 80% operations which takes place into any organization, these are read only. Up to 80% operations which happens in an organization, these are read only. Right, guys? Okay. So guys, we have a particular component known as Proxy SQL. And what does it do? So guys, Proxy SQL is responsible to identify the type of queries which is coming from this application server. This load balancer, once again, this will be like internal network load balancer. Maybe this could be the same instance. Like what we are going to do, guys, see, in order to consume our network load balancer in appropriate manner, what we can do, we can create one more listener, because see, end of the day, all the database servers, all the application servers, all the web servers, these are going to work in the same VPC. Are we clear with that? Do you agree with me? Yes, guys. Do you agree with me that all the applications,
Yes,
PBN and your app servers are going to work within the same network load, within the same VPC, right?
yes.
Great. So either we can create a new network load balancer in order to supply the traffic from these application servers to this DB server, or we can create, let us assume we are going to create an additional what? Listener onto this web server. Can we do that? Can we create multiple listener on the same network load balancer?
Yes, sir.
So it will not only help us while managing network load balancer, but guys, whenever we initiate any component, let us say we are going to create any network load balancer, so even that costs something, not only like creation, but let us say whatever amount of traffic we are trying to load balance with this, so first of all that will be charged. Moreover, the instance creation, the load balancer creation itself is chargeable, right? So why do we need to create multiple load balancers when we can attach multiple listeners onto same network load balancer? Until and unless the performance of that load balancer is not reducing, we shall be consuming it, right? So what, let us assume this load balancer and these are the same, right? So what we are going to say, that we once again have a net, like that will be up to you. If you think that will become more complex, that will be up to you. Otherwise, to save cost, and the ideology of an infrastructure goes like this. So we will have a separate load balancer. In order to save cost, you will say you will use only one, but the ideology says if you are going to use a load balancer for a separate component, that should ideally be separated, right? So we will have a load balancer here which will accept traffic on the listener port number. What is the listener port here? 6033. These applications will forward request onto this load balancer on port number 6033. This is just opposite port number of MySQL. Now, this particular component known as Proxy SQL is going to work as a load balancer for these instances. Right, guys? This Proxy SQL is going to work as a load balancer for this proxy. This particular piece of software will do one thing, that if any request which is going to come containing the query type read, except read, like it is alter, delete, update, insert, anything, alter, and any sort of request, that will be forwarded here. If the query type is select, then one by one, based on a particular round robin fashion, that particular load balance, that particular proxy SQL will keep on forwarding the request to this particular place, which is known as slave database. this load balancer will not be able to like bifurcate the type of request, will not be like identify the type of request, whether that is read or write. Guys, see, when we are talking about read and write, so even different type of queries, whether it is alter, insert, delete, right, drop, so every type of query is considered to be a write query, right guys? Are we clear with that, guys?
Yes, sir.
Any questions so far? So right now we have set up our like load balancer, like our database in HA mode, because we have the 3 instances. All the 3 instances are running in 3 different, all the 3 databases are running in 3 different availability zones. We have 3 application servers. We have all the servers running in different availability zones. We have 3 web servers running in 3 different availability zones. In order to ensure that the particular number of instances should be working as per expectation, so we have auto scaling group in place. We have a concept of launch configuration and on like launch template, in order to define, or in order to like defend when somebody is asking how will you ensure that all the available configuration on these servers will remain available onto the machines or onto the servers which will be created by this auto scaling group. Are we clear with that thing, guys? Any questions so far? If you have, please ask.
So, Lokesh, so how it will help about how to search the just like write, read, write any database now? So how it will go directly with the master or slab, or because if it will go directly with slab, how to identify this is a new request, writing, read, writing, or old request?
Okay, so when we talk about proxy SQL shift, so at that moment, what happens here? So this proxy SQL is an intelligent proxy SQL. So it does not contain data. It contains only like couple of things, that the type of queries it can identify. This is, you can say like this is able to read the schema of query. Like let us say if I am trying to select anything on a particular page, let us say I'm trying to like, let us say if I talk about Flipkart. Let me give you a practical example of it. For example, I am trying to look for mobiles, right? So if I go here and if I try to just figure out a couple of options here, let us say electronics, I want to look for some Samsung mobiles. So if I do anything, let us say I want to hit on view all. So if you see what sort of operation I'm doing, I'm selecting it. So is it a read operation or write operation? I have selected this, which means this is a read operation. Moreover, I do not only want to compare Samsung, but I want to include, let us say, MI and Apple as well. So once again, this is a read operation. If I select Apple, once again, that is going to be read operation like select. It will become a query like select asterisk where product is equal to Samsung, or like where product like Samsung, comma, MI, comma, Apple, which means I am going to run a select query. But let us say, if I am not a customer, I am a vendor. Let us say the particular mobile who is selling, the vendor of that this mobile selling is Lokendra Singh, right? So I have a particular option that I can log in from some different portal wherein I want to modify the price of this. Right now it is 23,999. I want to make it like 22,999, or maybe I want to increase it to 24,000 rupees, right? Just a single rupee I want to increase. So in that case, whenever I am trying to modify this particular value, it means this particular value is coming from some databases, right, Shiv?
Yes, yes, yes.
So in that case, this will be considered as update, and this particular SQL, this proxy SQL, this is additional software. This understands the particular query type, whether that is update or that is select. If it is select, it will forward request here in like round robin fashion. If it is update, then this will forward request here.
Got it. But any idea with any chart or something, it will go, which request will go to the master initially, just like that you explain good way. Select request will come from the slab. Some other thing, some chart type, so we can understand more for practical also or for interview purpose also.
Okay, so let me tell you. So Proxy SQL. This is a high performance open source SQL system. So if you go through this, you will get to know like what are the type of queries. Like let us say HTTP request, it can convert like proxy SQL cluster, like write traffic source will be here, read traffic source will be here. Then after, if you want to know about like what are the type of queries, like what is considered to be write and what is considered to be read. So only select queries considered to be read.
Okay. Thank you. We'll read this. No.
Yeah, only select query is considered to be read query. Otherwise, everything except select is write query. Be it is alter, update, insert, any sort of query is considered to be right. Guys, one more thing. For example, it could be possible that if someone is going to ask you, okay, won't you think that it will become a single point of failure? This proxy SQL. Okay, what if this goes down? Then what will happen? What would happen, guys?
It's a single point of failure. You should cluster it.
Guys, keep this thing in mind. If someone is going to ask you that query, so you need to have an upfront answer that we have two SQL proxy running in our environment. Both are replica of one another. That if any instance goes down, another will get up or will be like up and running, and that will also have the same configuration. So it will start forwarding request onto these. Or not this, if you don't want to say like that, so you can say that both the servers are running in active, both are replica of one another, right? So whenever we feel that any instance is going to go down, let us say if this instance goes down, this will up and running, this will be up and running, and if this goes down, like another one will automatically come up. Moreover, if you want, you can place an auto scaling group on the top of this as well, but no auto scaling group can be configured on the top of databases, because let us say we have configured a rule that if load is going beyond 80% on any server, then terminate that. Then guys, keep this thing in mind. Auto scaling group does not identify, does not recognize the application running inside that server. Auto scaling group will terminate that, and if you have to delete your database, that will not be recovered. So a person during interview might be interested in knowing that, okay, have you configured auto scaling group on the top of a database? So you will have to say no. Based on the requirement, you scale the databases manually. And this is not a particular bad thing, guys. Most of organizations are doing this in manual way only. Because let us say, if due to any unforeseen reason, if our database gets corrupted, million of requests are coming every single second, and because of high load, because of number of because of latency, because of any other issue, this load balancer, this auto scaling group, for instance, let us say I'm going to place it for a while. Let us say we have an auto scaling group here, right? What if this auto scaling group removed this instance? What would happen? As soon as this master will be terminated, even these slaves will stop working. Right, guys? That is why it is not recommended to configure any auto scaling group on the top of these database servers. Now, guys, if you have any sort of questions, you can please ask. Otherwise, let us move ahead with next course of discussion.
Quick question. Is this Proxy SQL is only meant for MySQL database, or it will work for Oracle or SQL Server?
This works with Proxy as well as MySQL. Or for Oracle, it does not. But Oracle has some sort of like virtual IPs based on which you can define that, like high availability. There are some different.
This particular one.
Like, because right now when I was talking example of MySQL, that's why I introduced this. Otherwise, like, and one more thing, guys. So Oracle and Postgres, Maria, Cassandra, these are really highly scalable databases. These actually do not have some sort of like performance issues as MySQL has. That's why this additional software has been introduced by communities. Right, guys? Okay. Now,
Yeah. Hi, sir.
please
I
go.
have one question
Please go ahead.
regarding auto scaling. So if my instance type is T2 micro, so I want to upgrade to T3 large or something, but it's connected with auto scaling group and without affecting the application, how we can upgrade?
Okay, very good. So the particular launch configuration template or launch template or launch configuration which you have, which is associated with the auto scaling group. So you will create a new launch template or new configuration group wherein you will remove existing instance type. You will not remove the instances. You will just modify the launch template wherein the same AMI will be used, which is currently being used, but you will remove T2 micro type of instances from your launch template or launch configuration. You will associate newly created launch template with existing auto scaling group and you will refresh the instances. When you will hit refresh instances, it will ask you whether like how many percentage of instance would you want to be healthy at any given point in time. You will define 60%. So what it will do, let us say if we have 5 instances, it will terminate 2. Then it will create 2, or you can say so like first of all it will create 2 additional. Once these are up and running, then it will terminate 2. Once again it will terminate 2. It will create more 2 instances once your existing T2 micro type of 2 instances are deleted. So like within batch of 2 instances that will keep on creating new. Once these are in service, this will start deleting old one. This particular task will be performed in 3 steps, 2, 2 and 1, because overall you have a number of instances 5. So doing this particular way, you will be able to achieve that like requirement which you have that says that you need to revise or you need to like increase hardware on your running auto scaling group. Clear?
Yes.
Okay. Now one more thing. So how do we? Okay, one more thing, guys. See, like guys, this particular is going to grow for sure, because when we talk about real-time infrastructure architecture view, so guys, this will take 2 days to get completed. At least it takes 3 hours. Right, guys? So please bear with me. Okay. Now someone is going to ask you, okay, that is fine, but how do you handle deployments? Because when we are talking about DevOps, so if a person does not touch upon deployment, that will not be a good idea. So a person might ask you, okay, like where do you have your VCS, version control system, or you can call it Git. So guys, knowingly I am placing it half in and half out. VCS means version control system, or you can call it SCM, source code management. So either it could be outside VPC or it could be running on any EC2 machine inside VPC. So I am going to make it like this, like either it could be outside or it could be inside. If it is outside, guys, keep this thing in mind. If it is outside, then how you are going to say that we are using Bitbucket, or we are using GitHub, or we are using like code commit. So code commit is a particular software or is a particular service which is provided from the side of AWS itself. So in that case, that will also be out of your VPC. Your code commit will be out of your VPC only. And that will have connectivity to like these instances. But guys, keep this thing in mind. When we are talking about this particular deployment section, so we will have a particular component known as Jenkins here. So guys, this Jenkins piece we are going to talk about. Okay, let us make it a little large. Okay, so guys, we have integration of this Jenkins to this Git or GitHub, whatever you know, whatever you call it, right, guys? Now, this Jenkins will have connectivity with each of the servers created in your infrastructure. Keep this thing in mind, guys. Like this particular Jenkins server will have SSH based authentication. Let me define here SSH. Let me reduce the size of it to 24 only. Okay, that's great. Yes, guys. So we have connectivity based on, okay. So guys, we have SSH based connectivity from Jenkins to all the web server. Like key based authentication we have from Jenkins to web server and from Jenkins to your application servers as well. Moreover, now there can be things like how Jenkins will be able to connect with those servers which are yet to be created, which will be created with the help of this auto scaling group. So guys, if you know, we created the AMI out of this, which means this application server and this web server already has the SSH private keys, sorry, SSH public keys inside it. So whenever new servers will be created, by default, these particular servers will authenticate this Jenkins server to be able to log into these application servers. Clear?
Yes, sir.
Okay. Now let's talk about that what type of deployment do we have. So guys, there are different type of methodologies which we usually follow for deployment. First of all, it is like blue green, which is mostly famous. But guys, we need like just double the infrastructure in order to go for blue green. On cloud, it is really easy to go for blue green because we need to have like additional amount of servers, maybe for a couple of minutes only, maybe 5 or 10, maybe half an hour or so. But when we talk about like on-prem, so like performing blue green deployment is really a difficult task. Why is that so? For example, if we have 1,000 servers, and in order, like let us say out of 1,000 servers, 700 servers are those where web servers or application servers are running. So we need like application and web servers into two, just double the amount of web servers we need in each data center, whether it is your main data center, your DR site, or like wherever you are running your application. So we will talk about DR later on. Okay, guys, keep this thing in mind. Like we have Jenkins for doing deployment onto these servers. Jenkins is authenticated along with these servers with the help of SSH protocol. Moreover, when we talk about monitoring, we have Prometheus for monitoring, right guys? So Prometheus is basically a tool which works very good if it is combined with Grafana. Prometheus plus Grafana is a really good combination. Right, guys? So Prometheus requires, let us say we are running here web server, right? So in order to monitor any service, Prometheus requires only one thing, and the particular thing is known as exporters. So some exporters are installed here. Because guys, when we are talking about like infrastructure monitoring, so that will not only monitor your application server, not only it will monitor your web servers, everything it will monitor. Moreover, you can monitor your CloudWatch metrics. You can say, okay, why we are going to use Prometheus when we have CloudWatch in AWS. So guys, keep this thing in mind. AWS CloudWatch is responsible only to monitor your web servers. But let us say you are running the EC2 machine, you can monitor with the help of CloudWatch. But what about the particular component which is running inside that particular EC2 machine? For example, you are running Nginx. Guys, have you ever observed that anyone is monitoring Nginx with the help of CloudWatch? Yes, guys, have you ever observed anyone monitoring Nginx with CloudWatch?
No.
And why is that so, guys? We need to remember that fact that whenever we are talking about this particular concept, so Prometheus and Grafana are the best tool to monitor. And guys, first of all, we will have Node exporter, then after we will have Nginx exporter, we have Apache exporter. So guys, multiple exporters will be installed inside these tools, and then Prometheus will keep on fetching data from these servers. Not customer data, guys, but the particular matrices which we need to monitor. And guys, Grafana is going to provide you a particular visual interface where you can see all the metrics in very beautiful color combination. Like it is really awesome. Those who are familiar with Grafana, that is good. Those who are not, you can try to set it up.
So
Grafana.
what is exporters?
So exporters are the agents which are responsible to read metrics and to supply the metrics to Prometheus. Prometheus is basically a monitoring engine, just like Nagios, like New Relic, like Datadog, like Splunk, like AppDynamics, like JabX. This is a monitoring tool, Prometheus, and Grafana is a particular dashboard. And these exporters, so let me tell you something about exporters with spelling is mistake, don't worry.
So exporters only doing the push operation or pull of pull?
So basically it works on pull mechanism. Nginx will pull the data from these exporters after every specific amount of time, whatever we are going to define. So guys, these are the exporters available like Aerospike, ClickHouse, Consul, Couchbase, CouchDB, Druid, Elasticsearch, Event Store. Well, there's a long list basically. These many components as of today, what do I say? Prometheus can monitor. So I guess we are clear with this as well. The connectivity towards all the components, whether it is your web server, your app server, your DB servers, will be enabled from your Prometheus server. Your Prometheus, your monitoring engine, your Jenkins, and let us say if we are going to talk about some sort of other components, be it is, what do I call? Let us say we are talking about Ansible for automation purpose. Either we can install Ansible along with the same server, which is known as Jenkins. We can club these two machines because sometimes it is required. Yeah. Or you can say like in most of cases, it is seen that Jenkins and Ansible are installed on the same server because sometimes it happens that we need to execute Ansible playbook along with the Jenkins pipeline. So we can install Ansible and Jenkins on the same server because end of the day, Jenkins is going to do deployment on port number 22, which is of SSH. Ansible is going to perform all the operation based on SSH only. So we can club both servers. We can have the we can increase hardware a little, but yes, we can install both the machines. We can install both the softwares on the same machine and we can consume that in such a way. So are we clear with this thing, guys?
Yes, sir.
Okay, so any questions so far, guys? Guys, any questions so far?
No, we're good.
I have a question.
Yeah, please go ahead.
Will Prometheus monitor the Jenkins server too?
Prometheus can monitor Jenkins as well. Yes, you're right.
Oh, okay.
Okay, any other question, guys? Shiv, any question?
No, thanks.
Okay, great. So I must say that tomorrow, let me tell you the agenda for next class, which is going to happen on Monday. So guys, we are going to talk about the integration, like how do we integrate Jenkins with these web servers? How do we integrate Jenkins with GitHub? What are the protocols do we use? What sort of additional points we have when we talk about Jenkins? So what other components are associated with it? Let us say we will discuss about SonarQube, right? We will talk about code quality gate. Moreover, we will talk about here, what do we call it? Like Artifactory. Or maybe we can talk about JFrog Artifactory, or maybe Nexus, any sort of thing. So these sort of component we are going to talk about in coming session. Moreover, what sort of deployment methodology do we follow? Like it is like build once, deploy many. It is blue green. It is like what? That sort of. I'm just giving you an agenda like what we are going to perform on Monday. And I would like to call it a day to day, because you see, if I start discussing about these integrations, so that will take really long time, guys. And moreover, like still one more thing is pending, which I would like to give a walkthrough like quickly. So that is log management. A person might ask you, okay, let us say when you are talking that you have a really large infrastructure, like you have 50 web servers, you have 200 application servers, how do you handle logs? So for that, guys, we have a centralized server, which is known as ELK. We will talk about ELK, Elasticsearch Log Station Kibana. We fetch the logs from individual application servers and we store the logs here centralized on a centralized location. Then after, guys, what happens? We just create a dashboard. So what is going to happen? This is not working, guys. I don't know why.
But if you're using AWS, you can use a Cloud Trail, right? That is also kind of a log management. Right?
Both are different. And when do I say like both are different? So we need to understand this particular thing. So Cloud Trail will only be responsible to track the logs of API level of AWS itself. We need to understand that particular thing, that AWS Cloud Trail will capture the logs. Let us say if I'm here, this is one instance which is running. Like, so if I click on this particular instance, if I select this, I go here, like let's say I go to actions, right? I try to go to security. I try to modify IAM role. If I select any IAM role here, let us say if I update this, then this particular activity will be tracked here. But if I log into this EC2 machine, I stop my services which are running on this particular server, those activity will not be tracked by CloudTrail. My CloudTrail will be able to capture this activity which I have performed, like I have deleted this. What? I have deleted this Linux machine. This will capture this activity, but obviously, guys, this will not be able to capture the activity which we are going to perform inside this EC2 machine. That activity will be captured with the help of ELK. Like how many requests are coming, how many are successful, how many are failed. So ELK section we are going to discuss in coming session, like how do we integrate, what sort of logs do we fetch, what sort of dashboard do we have, right? That sort of component we are going to discuss in detail.
Okay, sir, I have one question.
Yeah.
So Prometheus is also log collector, right? So why we are like
Prometheus
organization?
is not log collector. Prometheus is metrics collector related to an application, related to server, related to disk. Prometheus is not going to capture the logs. This is going to like logs and metrics are two different things. For example, this web server or this application server is responding very slow. Users are getting frustrated. So the average response type of my application remains, let us say, 15 milliseconds. This application server is responding to my customer in 250 milliseconds. My customers do not wait more than 150. So it means whether this application server is working, but the satisfaction level of my users is becoming frustrated, which means if this works or not, that is equal to nothing for me. So Prometheus is going to capture the like latency, response time, request time, like response time, latency between two applications, everything it can capture, but it will not capture the logs.
Okay.
It's like a cloud watch, right? It's like a cloud watch. Again.
Yeah, it is like cloud watch, but it can monitor the applications which are running inside your EC2 machines as well. Not only the metrics which your cloud watch will capture, but along with that, it will start capturing the metrics which are not captured by CloudWatch.
Okay, and the APM are different. Application performance monitoring.
Yes,
those tools are different.
Yes, APM can be integrated along with this ELK. So let us say there are like 5 applications working all together. Like what application is depending on what other application. End of the day, let us say if I'm trying to access this particular website known as servergam.com, right? So my request is forwarded to this particular web server. This web server's response is quite slow. This web server, this is working fine, but the hardware of this particular application server is quite low. Let us say this has 8 CPU, this has only 2. This has 32 GB of RAM, this has only 8. Right? So the performance of this web server is quite slow. Database is working good, everything works fine, but this is slow. So if I have to identify that at which particular point the user is getting slow response, so you can go to APM, application performance monitoring, that will create a trace of your request that will show that first of all your request traveled through this, then after through this load balancer forwarded to this server, and here it will create a spike like this, that it took maybe 200 milliseconds to get response from this web server. Moreover, it will generate a graph like when this application server processed the request and sent to this DB, and the response coming time, that was only 10 milliseconds. When this application server was processing request in order to verify whether the response is right or not, once again it took maybe 300 milliseconds. It forwarded to this web server. This web server took maybe 20 milliseconds, and it forwarded back. Overall response time for this customer was, let us say, 2 seconds. So out of those 2 seconds, 600 milliseconds, maybe 700 milliseconds was spent onto this particular server only. So you can get to know like which particular piece of application is working well, which particular piece of application is not working well. That is known as APM, application performance monitoring.
Those are mostly like supposed to use in like microservices architecture, right? Because in microservices pods
Yes.
and that getting crashed. Yes.
Ideally, that is supposed to be used in microservice architecture. But yes, if you have multiple monolithic applications which are working like with hand in hand with one another, then you can implement in like monolithic as well. But the ideal way to use here is in microservice, because there are a lot of microservices which are really hard to track.
So is it possible sometime to like please explain the microservices architecture as well?
Well,
like,
sure, need not to worry. So like
yes,
when I said if I start explaining, so this is like microservice architecture view. So this is monolithic. When we will
yes.
talk about in Monday session, we are going to talk about like if it is monolithic, how will it work? Let us say if like how do we isolate the service? Let us say it is login. Let me once again go to Flipkart. Okay, we will go to Monday. Not a problem.
Okay. Yes.
I'll explain that microservice architecture as well.
Yes.
So guys, any feedback for the session? If you have any.
Yeah, it's very good. Good session.
Good session, look.
So I have
Great,
one
as
query.
always.
So are you providing any notes for this?
So this recorded session will be shared with you. You can create notes as per your requirement, because if I share my notes, it will be really difficult for you to understand.
Okay.
Because studying from others' notes is really tough thing. So you can create your own notes. I'm going to share this complete recorded session with you after every single class.
Okay.
Okay, sir, may I ask something like if some query arises, so what is the best time to call you so that wouldn't be disturb your existing work?
So I cannot say anything about time. Whenever you call, if I'm free, I'll pick. If I'm not, I'll give a call back.
Okay.
Because there is no free time.
Okay, sir.
Okay, guys, thank you so very much. Thank you, everyone. I'm going to stop recording of this particular session. It was really nice discussing with you. Have a happy weekend ahead.
So that is the WhatsApp group which created already?
Yes, there is a WhatsApp group which is created for registered candidates only. Right. So from Monday, we will be going forward with registered candidates.
So you will sharing this recording to this group only, Lokinder?
Yes. No, this particular recording will be forwarded to everyone via YouTube. Monday onwards, it will be shared within that separate group only.
Okay.
Yeah. Thank you. Thank you, everyone.